Hello, in this video tutorial we will see how to save versions of the area, create key assumptions and use them in the expression builder. This exercise is similar to the one in the basic tools chapter of the WEAP tutorial. It is useful to create key assumptions to manage WEAP variables, especially when creating scenarios. In many cases, they serve to organize the model. A key assumption can be linked as many times as required. For example, suppose we have 10 population demand sites. If we consider that the annual water use rate will be the same, we could create a key assumption for this variable and link it to all population demands. If we change the key assumption value, the annual water use rate of the 10 population demands will change. You will not have to edit one by one. We will create 3 key assumptions using the following data. The annual water use rate for big city is 300 cubic meters per year, and for agriculture is 3,500 cubic meters per year. We are going to add a monthly variation for the big city demand. In the model that we developed in the WEAP in 1 hour video tutorial, the annual water use rates were the same, but we did not enter any monthly variation for big city. Go to WEAP. Remember that we are working on this model, which has a main river and 2 demands, big city and agriculture. We drew the river from upstream to downstream. The demand sites are already characterized. We entered the expressions in the annual activity level, annual water use rates, monthly variation, and consumption variables. Each demand site has a transmission link and a return flow. To save the model in WEAP, we go to the Area option at the top and select the Save option. Save As is used to make a copy of our model. Save version is used to save the model in a specific state. It is the equivalent of the undo function in WEAP. Suppose you save a version of the model, and then you continue to make changes. At some point, you want to undo those changes. Because you saved the version before making changes, you can return to that previous state of the model by going to the previous version at any time. If you would not have saved that version of the model, you cannot undo those changes. Before going to the previous version, it is recommended to save that version, or you will lose the changes made since the last saved version. You can save as many versions as you need. Just keep in mind that each version takes up hard disk space. It is possible to manage the model and its versions by going to Area Manage Areas. WEAP does not have an undo or redo function. The way to revert the model to an earlier state is to save versions before making changes. WEAP save versions as you work on models. However, as versions accumulate, WEAP will remove some of these previous versions. WEAP does not delete any saved versions, only the versions that WEAP saves. Because we will make changes to the model and we do not want to lose this state of the model, go to Area Save Version. You need to add a comment to save the version. This is useful for identifying the version in the future, to know easily what state of the model was saved. For example, first elements and data. OK. If we go to Area, Reverse to Version, we will see that version of the model. Those who have not followed all the videos in order and do not have the model in this state can follow this video tutorial by downloading the O5 Basic Tools folder. Close WEAP and double-click on the Say Training model to open the model. Go to the WEAP in 1 hour version. Area, Revert to Version, WEAP in 1 hour. As we saw in the WEAP in 1 hour video tutorial, the data can be entered by right-clicking on the element, selecting Edit Data, and then the variable. For example, big city, right-click on it, Edit Data, select the annual water use rate variable. You will be redirected to the data view, where you can enter the information for the variable here. What we want to do is use key assumptions and learn their functionality within the model. We can reference key assumptions in expressions elsewhere in WEAP. We can create them for controlling all the major modeling assumptions. To create a key assumption branch, we must be in the data view. Then right-click on the Key Assumptions category or other existing key assumption under which you want to add the new branch and choose Add from the menu. A new branch will appear with the name New Branch highlighted for you to type a new name. Name it as Unit Domestic Water Use. Add another one, Unit Irrigation Water Needs. And the last one for the monthly variation, name it Domestic Variation. Select the Key Assumptions category to enter the data to all these key assumptions simultaneously. Enter 300 for the unit domestic water use, 3,500 for the unit irrigation water needs. For the domestic variation, we will use the monthly time series wizard option. Enter the data in the table. Double-check the data and the graph. Then click on Finish. Remember that we could have used the Excel file monthly values. The monthly values are changed in the file. Once we are done, we copy and paste the expression into the WEAP variable. We have already assigned the values to the key assumptions we created. It is also important to assign them the unit. Set the unit as cubic meters for the 3 key assumptions: the unit domestic water use, the unit irrigation water needs, and domestic variation. Go to the volume category and select cubic meters. Once you have the key assumptions created, the next step is to link them to the variables. Go to Demand Sites and select the annual water use rate under water use. Click on the down arrow on the right side of the Big City expression box and choose Expression Builder from the menu. The Expression Builder helps you construct WEAP expressions by dragging and dropping the functions and WEAP branches into the editing box. Delete the current expression. Go to the Key Assumptions category, expand it, drag the unit domestic water use, and drop it into the editing box. We should always check the variable and the element. For example, Demand Sites, Big City, Annual Water Use Rate. When you are done, click on Finish. We are going to do the same for agriculture. Select the Expression Builder option and link the Unit Irrigation Water Needs key assumption. Drag and drop it. We are editing Demand Sites, Agriculture, Annual Water Use Rate. This is okay. Click on Finish. We see 300 cubic meters for Big City because we assigned 300 cubic meters to the unit domestic water use key assumption. It will be the same for agriculture. The unit irrigation water needs key assumption has an assigned value of 3,500 cubic meters. These values did not change. The difference is that now to change these values, we need to assign a new value for the key assumptions to change these annual water use rate values. The key assumptions are linked to these variables. We will link the domestic variation key assumption to the monthly variation variable for the Big City demand. Select the Expression Builder option. In WEAP, The monthly variation variable must be entered in percentage, and we have the key assumption in cubic meters. We can convert these values here. The sum of this data is 300 cubic meters, which is equivalent to the annual water use rate. We can divide the domestic variation values by the unit domestic water use and multiply that value by 100 to convert the data from cubic meters to percentages. Drag and drop the key assumptions while you construct the mathematical expression. You should have this expression. Always check the variable and the element where you are entering the expression. Also check the unit in which you must enter the expression. This is okay. Click on Finish. So far, we created the three key assumptions and we linked them to the variables. Go to the results view. Yes, we want to recalculate. We will explore the results to see if there is any difference in the water demand or the coverage when using those key assumption values. These are the results without the key assumptions changes. The agriculture net demand was 350 cubic meters per year, and for the big city was 240 cubic meters per year, for a total of 590 cubic meters per year. This will be the monthly distribution. This is the coverage. There was a deficit in February, August, September, and December for the domestic demand. In the WEAP 1-hour video tutorial, we learned how to explore the results in WEAP. Go to Demand, Water Demand in the first drop-down menu. Go to the table to see the values. The annual demand does not change. 350 cubic meters for agriculture and 240 cubic meters for the big city. We do not change any data to affect the annual demand, nor the annual activity level, nor the annual water use rate change. We use key assumptions, but they had the same value. The annual demand monthly distribution does change because we enter a different monthly variation for the big city. Check the results for the coverage. Select demand coverage. The coverage changed in February, August, September, and December. In December, the coverage is 100% for the big city. It was around 92%. The coverage changed because now the monthly percentage distribution is different for the big city. Go to the data view to check the table of the monthly variation for the big city. Copy this expression for agriculture and delete it to compare with the values we've assigned by default. Remember that the default values depend on the time step boundary option selected in the years and time steps window. Before linking the key assumptions, we were using the default values for big city. With this change, we see that the water requirement increases in June, July, and August, and decreases in January and December. Paste the expression again. Go back to the results view. Yes, I want to recalculate. Because the monthly variation is lower in December, the coverage is 100%. The supply is sufficient. The monthly variation in August increased from 8.5% to 9.6%, so that the coverage decreases. You can continue exploring the results.